So for problem 2 on our first set, it says there's a turntable record that rotates at a rate of 33 1/3 revolutions per minute. It takes 60 seconds to come to rest when you begin to switch it off. So we can put down our time as 60 seconds. That's known. We can put down our omega initial as 33 1/3 revolutions per minute. Now I know that those units are absolutely no good, so I'm going to need to work on converting those into a unit that's better for us, which is radians per second. Then I'm coming to rest, so my omega final is going to be 0. My question asks me what is the magnitude of the angular acceleration and what's the number of revolutions it makes before coming to rest, so theta final. I'm going to get an answer in radians, but I'm going to have to convert to revolutions because that's what my question asks for. So the first thing we need to do is get rid of omega initial being 33 1/3 revolutions per minute. So here let's go in and we'll write that 33 1/3 revolutions per minute times 1 revolution, having 2 pi radians, and 1 minute, having 60 seconds. That will now be our omega initial. That's going to come out to be 1.11 times pi radians per second. So I'm just not multiplying the pi for laziness sake. So now let's just go in and we'll plug into any one of our equations that we're interested in. So in order to find, maybe let's find alpha first. So let's go for the omega final equals omega initial plus alpha t. Omega final from our list over there is 0. Omega initial, now in our proper units, is 1.1 times pi. Our alpha is going to be a negative number, but we don't know what it is, so we'll leave it as alpha, and the time is 60 seconds. So we'll solve for alpha, and we're going to get that alpha equals negative 0.058 radians per second squared. So now we can go in and we can find theta using the alpha that we just got. So we're going to say that theta final equals theta initial plus omega initial times time plus 1/2 the alpha we found and time squared. So let's go ahead and plug that in. Theta final. We can usually call theta initial to be 0. You can define your 0 wherever you like, really. 0 plus omega initial times time plus 1/2 our acceleration, negative 0.058, and time squared. So when I solve for this, I get a theta final value of 104.8 radians, which is not really what the question asks for. It asks for how many revolutions happen. So I'm going to need to take this one step further and saying that I'm going to have to convert by saying that there are 2 pi radians in 1 rotation. That will tell me that I've completed 16.68 revolutions for this problem.